to Math 108, Module 15.4, adding, subtracting, and multiplying with radicals. So in this particular lecture video, I'm going to show you how to add and subtract with radicals. So when it comes to adding, subtracting radical expression, we can only add or subtract terms with the same index or same roots. And you also got to have the same radicand, all right, in order for us to combine them. So for example here, I got 3 times square root of 11 minus 6 times square root of 11. So we basically treating the square root of 11 like a variable, okay? So for this particular example, we basically just add and subtract its coefficient. So 3 of the square root of 11 subtract 6 more square root of 11 should give me negative 3 square root of 11. So like we talked about before, if you enter square root of 11 in the calculator, it's simply some sort of irrational number. So that's why we just keep on writing, write the answer as in radical form. All right, so now this one here, even though the roots are the same, but right now the radicand, what's inside the radical, is different. So we got to make sure they are the same before we combine them. So basically, I need to simplify this cube root of 40 first and see what that is. And then I can see if I can combine or not. Remember now, got to make sure the roots are the same and radicand, what's inside the roots, are the same before we can combine them. So let's break down 40. I'm going to use prime number 2 go into 40 20 times. 2 go into 20 10 times. And I know 10 is made up of 2 and 5. So since I'm dealing with the cube roots, I'm looking for 3 of the same number to go outside. So this will be a 5 right here. I'm looking for 3 of the same number to go outside as one of them. So these 3 2's will go outside as 1 2. This 5 got to stay inside the cube root. So cube root of 40 becomes 2 times cube root of 5. Then we're going to add on to another 8 more of those cube root of 5. So that should give me 10 of those cube root of 5. Okay? All right, so let's try this one, okay? So this one we got to simplify both of them, 50 and 72. So again, there are different ways we can do this. I've been breaking it down on the side using prime numbers. If you want to do a different way, that's fine. Sometimes I simply just write what times what is 50 right here, which is 5 times 10. All right. And 10 I know is 5 times 2 again. So sometimes I broke it down just right below my my radicand. So again, I'm looking for these two 5's to go outside the square root. So when they come out, they become 1 5. This 2 got to stay in the inside. Now in front of it, I already had a negative 7 times. So now this problem becomes negative 7 times square root of 2. Which will give me negative 35 times square root of 2. All right, let's break down this 72. I know 8 times 9 is 72. So I know 9 is 3 times 3. I know 8 is made out of 3 2's. So these 2 3's will go outside as one of them. These 2 2's will go outside as another one of them. Oh, sorry, put it in the wrong spot. I'm gonna put it right here. 2 3 go outside as 1, 2 2 go outside as another one. This 2 got to stay in the inside. So 3 times 2 will be 6 times square root of 2. So negative 35 square root of 2, subtract 6 more of those square root of 2. That should give me term with the same sign we add. That would be negative 41 square root of 2. So you can break it down on the side. Okay, or you can break it down right below. However you want to write it out, that will be fine. So to get out of square roots, we're looking for 2 of the same number to go outside. All right, let's take a look at this one. This one's not as bad. The first term, square root of 49, we know right away is 7. This y is only one of them, so they got to stay inside. Minus Remember now, this 4 is already out here. Square root of 25 will give me another 5 go on the outside. So that's really 20 times square root of 5. All right, minus 2 times square, excuse me, not 5, but y, minus 2 times square root of y. So all the roots are the same, all the radicals are the same, so I can combine them. So 7 minus 20 is negative 13. Negative 13 minus 5 is negative 15 of those square roots of y. All right, so here I just wrote square root of 25 is 5 times the 4 that was already up front, or negative 4 up front, give me negative 20. All right, some problems are easier to handle, some problems are a little bit aggravating. Like this one. This one's a little bit aggravating because if I want to break down 99 on the side here, I know prime number 3 can go to 99 33 times. Prime number 3 can go into 33 11 times. So once they get to 11, 11 is simply a prime number, only going to 1 time. So these two 3's will go outside as 1. And this 11 got to stay in the inside. All right. Remember now, on the outside, 6 and the 6a is already on the outside. This 1a and 1b cannot come out, so that stays in. So this first term is really 18a square root of 11ab. Be careful now. Make sure what we have on the outside is able to combine with other term as well. Okay. So because let's pretend if one of these 3 terms up here, let's just pretend if one of them is like a 7x, something like that. 7x cannot subtract 20 because those two are actually not like terms, the 7x and negative 20. Even though the radical part are the same, I still cannot combine them. So just be careful. I just want to mention that just in case if we run into it. Plus, okay, this 111 cannot go outside. 1a, 1b can go outside. So that term, second term is still going to be 9a times square root of 11ab. All right, 275 is a pretty big number. So let's break it down on the side here. 275. Oh, I'm going to use 5 first. I know 5 can go into it. Let me bring this over here. Sorry. 275 divided by 5. 55. Ooh, that sounds good. Because now 5 again will be 11. 11 is going to 11 one time. So these two 5's will go outside as one of them. All right, on the outside, I already got a 6 in the A. This 111 got to stay inside. The 1A, 1B stays inside. So this third term is really 30A times square root of 11AB. So far, all radicals are the same. Roots are the same. Radicals are the same. So when I'm combining like term, out here, 18A, positive 9A, positive 30A part is also like terms. So I can actually combine them. So that will give me 48 plus 9. 48 plus 9 got to be 57A times square root of 11AB. So when it comes to adding and subtracting radicals, we got to make sure what's inside the root, inside the radical are the same, and the roots or the index itself got to be the same before we can combine. So one last thing to check, make sure what's on the outside are like term with what's on the outside of another term before you combine them. All right, that will conclude this lecture video. Thank you for watching.